A very good day to all. So I'm happy to welcome you for another lecture on manufacturing process. So in this particular lecture, we'll be discussing a case study on casting process. So we have already discussed the topics on sand casting, pattern making allowances, pressure die casting, casting defects, and so on. So today we will discuss a specialized type of casting, which is called as ceramic casting. So a case study implemented by a foundry is discussed in this topic. So casting is a generalized process for making metal into required shape. So based on the application, different casting methods are employed. So if the requirement is low, then you will go with sand casting. If multiple parts of same design are required, you can go for investment casting. If intricate shapes are needed, you can go for pressure die casting. So in such cases, if you need a casting with very smooth surface, so in such case, you can go for this ceramic casting. So if you've seen any cast part, for example, the motor hub or your engine block. So everybody would have seen the water pump which are using in our household. If you see the outer body, it's generally made up of casting. You see the surface, if you notice the surface closely, you would have noticed that the surface will be a little bit uneven. It will not be very smooth compared to your inside parts of your pump. If you see your dynamo or the casing of your inner housing, it would be very smooth. If you see the bearing inside, it would be very, very smooth. If you get a chance to view the inside part of your pump or motor, you can see the bearing which would be situated inside, a bearing which houses the coils. So it will be very, very smooth in nature. But the outer body will be a little bit rough because it is made from sand casting. So even though you're using green sand and you are preparing it very, very carefully and meticulously, we will be using parting sand, etc. to make the surface smooth. Even then, the casting will have some grains on the surface. So if you need very, very smooth surface, then you have to go for secondary casting. So there is a method by which you can actually make smooth casting directly. So that case study is what we will be discussing today. So it is called a ceramic casting process. So as the name indicates, ceramic casting is done with the help of a ceramic. So ceramic we are using every day in our household applications, ceramic plates for eating, ceramic utensils, and also ceramic is used in insulations. So if you see your electric pole, there to separate one wire from another, they will be using ceramic rods. So it's a perfect insulator, and also it is a very, very smooth. It has very, very smooth surface. Hence, it is used as cooking utensils. They are scratch resistant also. They can withstand very high temperatures. They can withstand temperature up to 3000 degrees Celsius. They are refractory materials. So materials which can withstand temperature are called as refractory materials. So ceramics are classified under refractory materials. So what ceramic casting process actually does is, the pattern will be similar to your normal sand casting. Here it will be made of wood. So when the wood pattern is made, then what we'll do is we'll prepare a ceramic slurry. The ceramic slurry will be poured over the wooden pattern. So once the ceramic slurry is poured over the wooden pattern, it will be made to set for some time. So once it is set, what we'll do is you will put it in an oven and bake it. So what the baking process does is it hardens the ceramic. So similar to preparation of a clay pot, what you'll do, you'll prepare the shape of the clay and then you will cure it in by placing it in an oven. So once it is cured, then it will form a very hard surface. Similarly here, when ceramic is cured, it will form a very smooth and hard surface and a brittle material. So ceramic is a brittle material. So once the curing is done, what they will do is they will burn off the wooden pattern. So since the pattern is made of wood, it will be burned off. And the ceramic is being a refractory material. it will have no effect on the ceramic surface. So once the ceramic is prepared, it is called as mold now. So mold, we all know what is a mold is. So mold is the material on which molten metal will be poured to get the final casting. So now the ceramic mold is prepared. So then as usual, same process we will be following. So what we will do is we will pour molten metal on the surface of the ceramic casting. And once it solidifies, you can get the required shape. So as you can see here, an intricate turbine blade is being manufactured. So turbine blade has to be very, very smooth. The surface of turbine blade has to be very, very smooth in order to minimize the drag. So hence, such parts can be manufactured using this ceramic casting process. So detailed process is displayed here. So what first process is preparing a three-dimensional model, maybe plastic or wood. So then it will be immersed in a ceramic slurry. So once it is immersed in a ceramic slurry, coating will be done and then it will be cured. And once the curing is done, the ceramic mold will be removed from the pattern, and that mold will be used to pour the molten metal inside. And once the molten metal is poured, you can get the required output object. So what are the applications of this ceramic casting process? As I said, it is mainly used for preparation of turbine impeller blades. So they are very complex shapes. Turbine blades and impeller blades are very, very complex shapes with many curvature objects, and also they are very intricate in nature. So such objects can be easily manufactured using this ceramic casting process. So in industries where very high precision and very high surface finish are required, this ceramic casting process can be utilized. So I hope you understood today's topic. To give you a quick recap, today we discussed a case study on casting process. So the particular problem here is that very smooth surface finish is required. So by conventional sand casting process, smooth surface finish cannot be obtained. So for that, what you are doing, it's because of the sand mold. Since sand is grainy in nature, any casting produced will also have grain on its surface. So to overcome this, what you are doing is you are using ceramic as a material to prepare the mold cavity. So once the mold cavity is prepared using ceramic, the final output casting will have a very, very smooth surface, and also intricate shapes can be produced. In ceramic, it's a hard material. The mold cavity which we can produce will be of complex nature. Complex shaped mold cavity can be produced. So from that, complex castings can be produced. So application of the ceramic casting process is preparation of turbine blades, impeller blades, etc. So I hope you understood today's topic. We'll meet in yet another lecture video. Thank you.